Hello everyone, this is Technical Avant-Garde. Welcome back to the Arduino series, and this is the seventh lecture of Arduino series. And in the first lecture, in the last lectures, I sum up what we had done. We had done some basic questions on Arduino, and then turned on and off the LED, the onboard LED as well as the external LED. Then we blinked that same LED, and we blinked also the external LED. Then we have some good stuff, good technicality stuff on the breadboard, and that's it. And we learned also the analog write command, and we use that command. And then we had done the electronic stuff, that is the voltage divider, and we had learned that rule in the last lecture, voltage divider using the resistors. And we had done some mathematical calculation, as well as I had proved that mathematical calculations with the simulation using the LT Spice open source software. And today also we will be doing some electronic stuff, that's the Ohm's law. You people might be confused that why we are doing the Ohm's law, as you might know about the Ohm's law, but I think it should be done because many people in the interviews weren't able to answer what is Ohm's law. So it's the pretty short video. Today we'll be doing some theory part, and in the next lecture we will be doing the simulation of the Ohm's law. Without wasting time, let's start the lecture. And what is Ohm's law? It is the relation between the voltage, current, and resistance in any electrical circuit. It might be consisting of the capacitor or resistance, any circuit. It was firstly discovered by the German physicist George Ohm. That's why it's known as the Ohm's law. And he found that at the constant temperature, like if you are making the temperature at a fixed value, the electrical current flowing through a linear resistance, fixed linear resistance, like a resistor having the fixed resistance. Let's take the 12 ohm, and it is directly proportional to the voltage applied across it, and also inversely proportional to the resistance of that resistor. The relationship between the voltage, current, and resistance forms the basis of Ohm's law. I'll repeat the definition. The relationship between the voltage, current, and resistance in any DC electrical circuit was first discovered by the German physicist, which is the who is the George Ohm. And George Ohm found that at a constant temperature, the electrical current flowing through a fixed linear resistance is directly proportional to the voltage applied across that resistance, and it is also proportional to that value of the resistance. The relationship between voltage, current, and the resistance forms the basis of Ohm's law. As you can see on the screen, that current I equivalent to voltage V divided by resistance R, and the units, as you all know, current unit is ampere, A, voltage unit is V, volt, and resistance unit is ohm, as it is given by Ohm's law. And this is the I, V is equal to IR is the derived Ohm's law, but the exact Ohm's law is I is directly proportional to R, as per the definition I just given. So I is directly proportional to V. So to remove the directly proportional, we have to put any constant. So we had put the constant R, which is the resistance of that circuit through which the current is flowing, with the help of the voltage applied across that resistance. If you can also say that a voltage of 1 volt applied to the resistance of 1 ohm will cause a current of 1 ampere to flow. Like if you are giving us all the values as unit, like a voltage of 1 volt applied to a resistor of 1 ohm will cause a current of 1 ampere to flow through that resistor. And as you can see here, that any electrical device or component that obeys Ohm's law, that is the current flowing through it is directly proportional to the voltage across it. I is directly proportional to V, such as resistor, cables. That's the ohmic in nature. It will be ohmic in nature because the current flowing through that is directly proportional to voltage. And if it is not happening that such that in case of transistors and diodes, then those devices are the non-ohmic devices. Now we will come to the next topic, which is somewhat related to the Ohm's law, the electrical power. The electrical power P in a circuit is the rate at which energy is absorbed or produced within a circuit. It is denoted by P, and in the simplified way, it is the product of voltage multiplied by the current with a unit measurement of the watt, W. And these are the some units of the power, like millivolt, kilovolt, like 10 raised to power -3, 10 raised to power 3 respectively. Source of energy such as voltage produce or deliver power while connected to the load absorbs it. Light bulb example, the light bulbs and heaters are the examples, and they absorb electrical power and convert them into the heat or light or both. You can clearly see, you can clearly imagine these things. What I'm saying, a source of energy such as a voltage will produce or deliver power while the load is connected and absorbing that thing. And light bulb and heaters absorb the electrical power and convert that into the heat. So these consumes or absorbs the electrical power. These are some different formulas to compute the electrical power, like P is equal to V into I, like voltage into current, then V square divided by R, then I square divided by R. I think you all people know these formulas. So this is the sample circuit which we will be doing today. We will be doing today only the calculation part, and in the next lecture we will be doing the simulation part. And you can clearly see that we have given the voltage source as a 24 volt. We have to find the current, and the resistance is given is 12 ohm, and we will be we will be computing the power as well as the current. So what are the calculations? I have done the calculations with the help of the mathematical operations or formulas which I just explained. So these are the results. So current is equal to I is equal to V by R, as you can say with the help of the derived Ohms law. So 24 is your supplied voltage and the resistance is 12 ohms. So the current will flow through the circuit or through the resistance or the voltage source. It will be 2 amps, 2 ampere, and the power consumed by the load 12 volt, 12 ohm resistance. It will be the V into I, and I we had just found the 2 ampere. So 24 into 2 is equal to 48 watt. So you can clearly see in this schematic, the current is flowing 2 ampere in the circuit, as the circuit is series circuit. So the current will be the same for voltage source as well as for load, and the power consumption by the load resistance, which is 12 ohm, is 48 watt. Thanks for watching. If you found this lecture interesting, I'm sure it will be, and then please hit the like button and share this video to all your friends and the electronic enthusiasts. So more and more people can learn about the Ohm's law and all the videos you had learned till date. And if you have any doubt regarding any lecture till date, then you can ask in the comment section. I will definitely respond to your doubts. Stay safe, stay healthy. Meet you in the next lecture.